All right, welcome everyone. We'll wait a couple minutes to get started just to let people filter in. But thanks for joining us, and we look forward to kicking it off soon. Welcome to everyone who just joined. Give us a couple minutes and then we'll get going. So I'll target maybe 2-3 past the hour. Awesome, yeah, and we have, if you are tuning in from somewhere, feel free to put that in the chat just to see where everyone's coming in from. Got a good spread so far. All right, perfect. Yeah, people from all over joining us. That's always great to see. I'm actually out of our Boston office right now, but I think we're pretty good to get started. So I'll kick things off. So I am Claire. I'll be your MC for today, and we are lucky to have Ford here to talk about accelerating automotive design. We'll be using both SLA and SLS 3D printing. So our agenda today, I'll give you a little bit of a brief overview about Formlabs, and then we'll pass it over to Bruno to talk about how Ford uses our technologies on the SLA and SLS printers to design, how the printing is used in functional prototypes and testing, talk a little bit about scaling, and then we will open it up for a Q&A session. So if you have questions, the place to do that is actually over in the questions box. But before we get to the logistics of that, I am Claire Bartel. I'm a senior sales engineer here at Formlabs. Been on various teams here for a while, so excited to see more applications and some more customer stories. And I'll let Bruno introduce himself.
Hello, everybody. I'm Bruno Alves. I'm a prototype engineer in Germany.
Perfect. Thank you, Bruno. So for those Q&As, this looks a little bit different, but over on the right-hand side, you'll have a little bubble with a Q&A. If you can pop those in there, we'll be reviewing them and then taking them at the end. So feel free to use the chat throughout if you're excited, if you have comments about things. But if you want us to answer a question, pop it into that question box. And we have some polls. So if you, we are publishing a poll right now. If you could fill that out kind of through this introduction, you'll see a couple of those pop up. We like to just know how you're using 3D printing, kind of what you're excited about, and whether you'd like us to contact you. So fill those out when you have a chance. It looks like there are 2 live right now. So it looks like a good split between are using a printer, and haven't gotten one yet. But hopefully this session will help you decide and find new ways to use it. So a little introduction about Formlabs. The company was founded in 2011. At this point, we have over 130,000 printers shipped, multiple patents, multiple offices. We're global, and a lot of different printing technologies to use. So we are focused mostly on SLA and SLS. So SLA is resin printing in terms of printers that are out there now. We have the Form 4 and the Form 4L, as well as biocomp versions of those. We offer kind of a full workflow for materials, software, post-curing, washing, and we've been adding kind of new software features too. So we have a texturing engine. On the SLS side, we have the Fuse 1 plus 30 watt. That is mostly nylon, but we have some other materials. Great for kind of end use, durable parts, and full workflow on that as well. So you'll see in that picture the Swift post-processing station and the Fuse Blast, which is a media blaster to get powder off of those parts. So we like to enable people to print whatever they'd like to via both of those technologies. And in terms of materials, as you can see, we have a wide array of things here. Everything from prototyping to kind of end-use materials, casting materials. If you have any questions about capabilities there, feel free to contact us. We love talking about all of them. And on the SLS side, these are powder-based materials, so printing without support structures. Mostly nylon 12 here, but we do have some other high-performance materials. We have some composite materials, and then actually a flexible TPU as well. So a lot of different materials to fit what you're looking to do. And I will actually pass it over to Bruno now to talk about his experience with the technology, but keep popping those answers on the polls and put in your questions for the Q&A.
Thank you, Claire, for the introduction. Yeah, I start with a small introduction. So my name is Bruno Alves. I'm working for 13 years already at Ford Motor Company in Germany, in Cologne. So we are developing vehicles. We can see now in this image, one of the vehicles that we are producing in Cologne. Yes, this one was the first one full electric vehicle that we produce. Currently, we are having two. The other one is Capri. This is the Explorer. And we're really proud of this product. And why I'm here presenting this in Formlabs presentation is because we are really happy to use the machines and all the capabilities that these machines could offer in comparison to the past. So this is really a game changer, and I told already several times that in these 13 years, I see a lot of evolution, especially in software and also in machines. And I'm really happy to see the Formlabs going step by step and increasing the performance from the machines. So just a small presentation about Ford Motor Company. I think everybody here, and I'm really happy to see from all the world people. So we are seeing this sixth largest automaker globally. So it's a huge company, and we are really keen to produce a lot of vehicles mass production. For this, we need also to have, in a way of creating prototypes very fast, to have the best machines and all the best machinery that could be now in the market. So I'm working in Merkenich, so it's very near the mass production facility in Lille. So I'm developing the vehicles, the prototypes for the PD, product development area. So I'm really the lucky guy that put all the design CAD in physical models. So the engineers could put all together and make iterations and decide what the best design to meet the targets, and also to make the clients happy. So you can see here is one of the images that I'm using, Form 4. It's really a game changer. I don't know if everybody here had the chance to see this new machine from Formlabs. I can really say that it's more or less 3 times faster than the previous models. And this is really impressive, the speed. So there's also several parts that depends of each application. We have to select the right material. So you can see it here, the right side, I was testing rubber parts. The left side, I was testing materials in SLA. This is clear material, but depends of the engineering. This is the beauty thing in prototyping is we have the chance to tell to the engineers which material is the best, which process is the best. It's not only select laser sintering, cell lithography, or FDM. We can decide, okay, for this part, we can go to eye injection molding. For example, I can show you that some of the parts that we produce, we also are using eye injection molding. What injection molding has to do with 3D printing, it's simple. Sometimes we are not printing the part, we are printing the tools to produce the part by injection molding. So injection molding is a process that there's a lot of pressure involved, a lot of heat. So you can imagine having a machine pressing 300 bars into a tool. The tool will not hold if we decide, or if we take not the right material, not the right process for the tools. So that's really the key in this thing, to decide which material we need to use for the tools, also the inserts. So there's also here some images telling what kind of resin that you use. But again, this depends of the application. So there's applications that we go to SLS, especially for the engineers like to test, let's say a PA12. It's more similar to PA6. Rather than go to SLR, and then the parts are more fragile. And there's some quote from myself here saying that, yeah, some days ago, it was days to print parts. Now it takes only minutes. So it's really a game changer. Some years ago, if the engineer was come to us, we were saying, okay, you can come tomorrow or the day after. But now with this difference in advantage in high technology, we can print really in minutes, hours. So here you can see also images or a part that we printed in SLS, selective laser sintering, using PA12. As the engineer can test all the function from the parts several months even before kick off the tool for the injection molding. So several parts, or let's say several inserts for injection molding, they were printing with several different materials to test. Yeah, we have done, or we do some kind of iterations because sometimes we're not sure if the tool will hold. It's sometimes a question of changing and testing different materials to get the best approach. There's no, let's say, a sheet that says what material is the best. You have an idea, and then you have to decide, depending of the application, what will be the best. So if you have questions, so I'm seeing here a pool, number 2. I don't know, Claire, are you open the pool?
Perfect. So we have another poll up. If you can pop answers in that second poll about what your biggest barrier to getting started in 3D printing is, and then whether you'd like to be contacted by us later, pop those in and we'll take a look at those. Perfect. So a lot of people already 3D printing. Always nice to see. It looks like we've got most of those votes in, so we can go on to the next one, which is our Q&A. So let's see what we have here. I know we have one question about whether the recording will be available. Yes, it will be, so you can use the same link to view that. We have a question about using the wash tank. So I think it sounds like kind of a general question, so I'll take this one. In terms of, oh, perfect. Whether you're using one wash tank and how often you're cleaning the wash, I've seen kind of various things. So our form wash units, you don't necessarily have to clean that after every use. You can continue to use that solvent until it's saturated with the resin. So traditionally, mostly people are using isopropyl alcohol there. You can get a pretty good lifetime on that. Just keep washing those parts either until the hydrometer included kind of indicates you should change that isopropyl alcohol, or whether your parts are just not getting quite as clean, so you're following our recommendations. Parts aren't clean yet, I would change that isopropyl alcohol. The other thing to include here is that sometimes we like to separate certain materials, so either materials with a fill, like the rigid 10K that you saw in the injection molding molds that Bruno talked about. Sometimes that glass fill can get another color, so we like to separate that one. And then anything with a really kind of distinctive color, sometimes we'll separate. So we'll often have light washes and dark washes.
So Claire, there is a question, how many cycles the printed cavity resist? So maybe I can answer this. So depends, of course, of the geometry. Our goal is to take at least one or two parts, especially if we are using this kind of technology for, let's say, for crash test or let's say a mechanical test. But depends on the geometry and what's the request from the engineer.
Yeah, in terms of our testing, we have a white paper that you can search for on kind of process conditions, but we're generally seeing kind of anywhere from a couple to maybe a couple hundred, but it's not necessarily the same lifetime as a regular kind of metal traditional mold. We've got a question about whether you're using FDM printing as well at Ford. I don't know if you want to take that one.
Yes, we are using, but not as selective laser sintering, based on the fact that engineers they want to have material more similar to PA6, and also the quality of the parts are way better than FDM. But yes, we are using at Ford as well FDM.
Nice. I think we have a question about kind of your use of SLS as well. So are you using it for prototypes kind of as assemblies or individual parts?
Both. So the key thing is we print individual parts and then we make it assembly, these parts, in assemblies that the engineer can test. But we are making both. Yeah, I don't know if the question here assemblies it's referring to jigs and fixtures, and I think this question is more or less in this direction. And yes, we are using also for jigs and fixtures. There's some interesting videos on the internet from Ford as well about this.
Perfect. And we've got another one about kind of coloring for printed parts. Bruno, are you coloring the printed parts? If not, I can take this from our side.
Maybe you take the question.
Yeah, sure. So there are a number of ways to color the parts. It depends on the technology that you're using. So if you're on the resin side, so the SLA process, we actually have a color resin, so you can color the parts that way. You can also dye the isopropyl alcohol or some of the resin. There's going to be some printability effects due to that because you are changing kind of the chemistry of the resin. You can also paint them, you can coat them. So we've actually been doing some Cerakote coating, which is kind of a ceramic coating. That's great because it provides really nice color, UV resistant. It actually will block the SLA parts from UV. And it also is scratch resistant and has some nice properties. So kind of painting, coating, dyeing, all on the table. On the SLS side, you can also dye parts. So for our materials that start out kind of that dark gray, hard to get lighter colors from those, but you can get some nice kind of olive tones, kind of a deep maroon red. You can dye them black. That's pretty common in the industry. You could also paint and coat those as well. And we just came out with a white nylon, which is nice for dyeing lighter colors. So you'll see some kind of pastel colors on the parts. Let's see. So I think we got the tooling one. We have injection mold inserts out of PA12. Can you talk about your experience with that, Bruno?
Actually, I have a very good experience in PA12
Nice.
parts for inserts. The way I have a very good let's say feedback is because they are not so fragile. Of course, the surface quality will be more rough than parts printed in SLA, let's say in 10K. But in SLS, you can really produce parts and minimize the risk of having a failure in the tool. Several times we have printed parts, let's say the inserts, based on the fact that they will not break. So we decide to take SLS tools because they will not break.
Perfect, thank you. And then we've got a question here about the type of injection molding machine you were using. Do you happen to have those specs? I think it doesn't matter too much what the machine is as long as you set the characteristics, but if you happen to know, that would be helpful.
Yeah, so the injection molding is, let's say, a very, maybe I will say old technology, but didn't change so much the last years. So we are using a standard 90 tons and 160 tons machine. It's a basic for this. The only thing is that I can tell or give a little advice is the operator in the machine, they need to know exactly what they are doing. So not like they are using like a traditional tool made of aluminum or steel, but if they are using plastic, they need to really know exactly what kind of parameters they are putting in the machine. So one failure in some kind of percentage, second pressure, or it's enough to destroy the tool. So it's very important to know what kind of parameters are put in the machine to take parts.
Nice, perfect. And I see a question here about the nylon 12 mold inserts. I'll just take that one really quickly. So question about whether you have to use a Fuse 1 plus 30 watt, which is the get a newer version of the Fuse, or you can use a Fuse 1. They're all going to print that nylon 12, so feel free to use whichever one you'd like or that you have. Perfect. So there's a question here about Ford using additive manufacturing as kind of maintenance and spare parts. Bruno, is that something that you're doing? Something you've thought about doing?
Yeah, that's a very, very good question, Donald. Of course, let's say the low-hanging fruits is to use additive manufacturing for maintenance and for spare parts. Yeah, we are using it for spare parts, not so much, or I don't know if we are using spare parts based on the fact that, if the engineer produce or develop a part for injection molding in mass production, we cannot change afterwards the process. So if we will deliver spare parts using additive manufacturing, then the process needs to be changed. And currently, maintenance in the plants, in assembly plants, I think this is a low-hanging fruits for sure.
Perfect. I think there's a related one here as well. So talking about kind of maintenance and spare parts, but also production parts. Is this something kind of on your mind to use 3D printed parts for production? I think they have some specific things about kind of location within the vehicles too, but just as a general concept, yeah.
Yeah, we can speculate a lot, but I will not speculate, especially in these questions about using additive manufacturing in mass production.
Yeah.
We don't know the future, but yeah, I think that's the goal from or let's say the question that everybody has, if we can use it in mass production.
Yeah, and it's pretty at least the customers I've worked with, there are plenty of kind of regulations and testing too, so that's always a barrier.
Yeah, correct.
Let's see, we have one. I'll take a Cerakoting one. So the question is, are all SLA materials compatible with Cerakoting or powder coating? On the Cerakoting side, it makes the most sense to coat materials that are not flexible because that coating is not flexible. So kind of more in line with the general purpose materials, maybe a glass filled material like rigid 10K is a good fit for that coating. Powder coating can be a little bit tricky because sometimes that process requires just a fair amount of heat. So kind of keep in mind that it is a plastic material. There are maybe some powder coats that they're able to kind of go on 3D printed SLA materials, but not necessarily all of them. So kind of check with the coating contractor. We have a question about whether you're using kind of collapsible cores in your injection molds, Bruno. Is that something you've tried?
Yeah, very good. Yes. Yes, I think the easy thing is to use the inserts. So you can still use aluminum tool or metal tool, and then use inserts as let's say complicated geometries in printed. So it's a good thing.
Yeah, perfect. We've got another one about SLA resin materials and automotive fluids. Is that something that you've kind of tested or had experience with when you're testing those parts?
Yeah, I think SLA for automotive fluids it's used and it's a good idea, but you need to know or you need to see what kind of test you will perform. So if what kind of oil you use or benzene or if the material is suitable for that. I will say yes in SLR. Because if you use it SLS, you need to make some kind of coating or let's say infiltration to avoid this. SLA, you don't need to make this infiltration, but you need to be sure that the material that you are choosing will not degrade or not that in contact with this fluid.
Yeah, so if Mark, if you're using some of our materials, we have solvent compatibility for them. That's going to give you a general idea. And then, like Bruno was saying, I think the best way sometimes is to test it. So whether you have a printer kind of print things out, test them. If you don't, we can send you samples to do that testing on. We have a question about SLA printed threads and how to utilize threads. I'm not sure, Bruno, have you done that?
Both ways both ways work. The only thing is if you are printing threads, you need to be sure that they will be cleaned afterwards really good. So yeah, that's it, the only thing.
Yeah, and I'll add too that in terms of threaded inserts, one thing that I get questions about all the time is whether you can do heat set inserts, and on the SLA you cannot. So that material is not going to melt, and so you cannot kind of melt in those inserts. But threaded inserts you can do for sure.
Yeah. So I'm seeing here SLA. So you can use some kind of bushings with thread. So you just print a whole diameter, and then you put bushings. But yeah, for threads, I will not. Maybe it's not the best approach. Maybe SLS will be the best approach.
Yeah, I see them a lot in the SLS. Let's see, we've got kind of going back to the PA12 molds and kind of compensating those temperatures and pressures. Kind of any more comments here?
Not compensate the pressure, but we need to, let's say, give some kind of treatment if we are using, let's say, materials that use more temperature. Or so there's some tricky things that we need to do. Of course, I will not tell here what we have to do, but not the pressure. I will say that we'll not need to take measures to compensate the pressure. I think the thing is the temperature. Yeah.
Yeah, and you can also post machine molds. So we'll see that on the SLA, but also SLS parts too. If you really need kind of a nice kind of sealing surface on something, you can machine it after the fact. It'll get rid of some of that kind of SLS texture on your parts. Let's see. So we have a kind of question on warping on parts, and I can maybe take a first pass, and then if you have kind of extra comments, Bruno, we can.
Warping. Yeah, warping is it's real. Of course, there's warping, especially in the cooling process. So if you don't take the necessary time to cool the parts, they will warp. And also, if the parts are in the chamber full of other parts, they will warp. There's some ways to mitigate this. So if you have the time to, let's say, or maybe the time, but the chance to print one part, to measure and to redesign the part and then to print it again. If not, you need to be sure that you are following the temperature, cooling temperature, for example, the distance between other parts. There will not be too much, so the heater will not. There will be a proper heat dissipation. So there are some things to mitigate this issue.
Yeah, so the biggest one that I'll usually tell customers is just orientation plays a huge role in what your parts turn out like. So if you're kind of seeing maybe a warped part, often we'll see that mostly on kind of long, thin parts that span the build volume, and that's kind of SLA and SLS alike. So orienting those things differently, putting the support structures on the SLA side in a different location, a lot of that can go huge kind of impacts on the parts. So play around with orientations, kind of get in touch with other 3D printing kind of teams, contact us if you have questions about specific parts, but generally try to kind of angle things and distribute them to help with that. Let's see what else we have here. There's a question about kind of steel tooling and die casts. If we can put that one in, yeah. Is this something that you're using, Bruno?
Yeah, it's a good question. Yeah, I think it's not new, so yeah, yes, it's the answer for this. Yeah.
Okay. Let's see.
So I'm just a little concerned. So try not to ask some kind of confidential questions. So
yeah, yeah,
be careful. So
fair enough.
Don't put me in a bad position.
Yes. Yeah. So if there's anything you can't answer, just say confidential, and we'll move it out. Sometimes it's hard to tell ahead of time. Let's see. We've got some kind of 3D printing questions about production. I think some of those may venture into that territory, so may not choose a couple of those. Let's see. So we have another question about kind of injection molding tooling here from Victor. Are the holes shown kind of drill holes? Are those threaded? I think that's in regards to that kind of smaller injection mold in the rigid 10K.
Yeah, it's also yeah, you can make threads, or we can make threads in the inserts. Then the operator needs then to disassemble. So for prototypes, no makes sense to make some kind of mechanisms, automatic mechanism. So the operator then needs to remove the thread. Yeah.
Perfect. Yeah, and I see another question from Victor here about the software. And they're asking whether you can kind of batch models together. So I can take this one. In terms of kind of saving things as a project, not exactly sure what this question is asking, but there are a couple of things you can do. So there is kind of a model list in Freeform. What I'll do to save kind of batches is just save them all in that one job. And then especially if I'm doing maybe they don't fit on a build platform or a build volume in general. So I'll just uncheck half of those and then kind of print the rest, and then uncheck the other half and print the rest. On the SLS side, we recently introduced part cages. So essentially that is a printed cage that surrounds those parts. So those parts, for those less familiar, are kind of floating in space and powder is supporting them. So they're not kind of stuck to a build platform like they would be on maybe an FDM or an SLA printer. So those cages help keep parts together, and you can label those and say, left side of project, right side of project, kind of these models all together, and you can actually post-process them with that cage. So they kind of stay together all the way through the sandblasting at the end. There's another question about kind of using the Formlabs equipment to prototype for you, Bruno, and what that has meant for iteration and speed. If you can talk a little bit more. The question is from Brian.
Yeah, it was really a game changer. As I said, some years ago, let's say in 2015, we start to see a difference in kind of approach in software and machinery, that not only the professionals could use the machines, but everybody just plug and play just some hours and you can just print parts. And this speed up a lot, especially the operators. So they need to take huge lessons to learn how to learn how to use the equipment and also the software. And yeah, the iterations and the engineers now, they really are not afraid to test different designs, because they know that the parts will get very fast in comparative to some years ago.
Perfect. I'm just looking through the rest of the questions here. Kind of some about future roadmap, and can't say too much there, so we won't be taking those ones. And then there is an interesting one, if you can answer this, Bruno, kind of comments about additive manufacturing and how it's affecting the sustainability of the automotive industry. Kind of any kind of general thoughts, don't have to get too specific here.
Yeah, there's a very good question. I'm also making some kind of research, especially in this word sustainability, because especially in SLS, what will happen to the powder if we are using 100%? How can we recycle this powder? How is the properties? So not maybe the question is not in the question of automotive direction, but in additive manufacturing. What can we do to improve this kind of question, to reuse the powders or the materials in the future? Yeah, I'm really happy that Formlabs is trying to reduce the ratio in SLS. So now currently for PA12 we are 70-30, and we can even go lower, taking some considerations. But yeah, that's a very good question. And I see that all the engineers are focused to reduce this percentage.
Mm-hmm. Yeah, and something that I hear fairly often is that it also just helps you avoid parts that maybe aren't efficient and you have to change them later, and that's kind of a huge material saving too. So parts are kind of great the first time because you had such a good opportunity to test them. We've got another question here about regular maintenance, and I can take this one. So in terms of kind of regular maintenance on the Formlabs machines, on the SLA side, really not much regular maintenance. What you want to do is make sure you're changing out that tank that holds the resin periodically on the Form 4 and 4L series printers. That is about 75,000 layers. So for a lot of people, that's maybe even an entire year before you need to change your tank. So just make sure that tank film looks good. Keep everything clean. So that light processing unit below that tank is something you want to keep clean, keep free of dust. You can wipe that off with a kind of lint-free cloth. On the SLS side, there's a little bit more that you need to do, but it's still fairly easy. So that machine will actually track maintenance tasks for you, and they run the range from kind of cleaning a surface with ethanol to vacuuming out a couple filters. Whenever I've started those jobs, it takes kind of no more than 5 minutes to do anything that pops up on that list, even if it's everything. So kind of some maintenance, not too much there. And then we do offer service plans for all those printers. So especially on the SLS side, that's important because there are things that we need to change out that we don't let customers do. So that is kind of anything to do with the laser and some gaskets we'll actually replace ourselves with our techs. We've got another question about SLS over SLA. I think in general, the big one that I see, and I'll let Bruno kind of make some comments also, is that if these are kind of end-use parts and they need to be used in an environment where maybe they're outside for a while, they're in contact with water for a while, they need to be UV stable. SLS is a great kind of solution for that. I think the SLA is a little bit less robust when you're talking about kind of really kind of UV, especially heavy applications. Yeah, and I think another benefit here is how much you care about support structures. So sometimes the SLA, for those that kind of don't have printers, you'll basically have a scaffolding that holds it onto the build plate. And that is something you need to remove after the fact. A little bit of sanding takes that off. But sometimes kind of every surface on a part is important. And so if you can't get around kind of orienting it a certain way and setting it up a certain way, the SLS is a great solution because the powder is what's going to support the part as it's printing. There's a question about reducing the pillar thickness in a preform support. So that's a good question. Most of what you can control is actually the touch point size. So this is about those support structures on the SLA printers. There is not much control over kind of the geometry of the rest of the scaffolding, but the part that tends to be most impactful for your part quality is just how much is contacting that model. So you can set that, but you can't set the thickness. We've got another kind of workflow related question from Victor about storing the resin. So at least in all of our Formlabs machines, you would store that resin actually in the resin tank. So our resin will come in cartridges and that dispenses into the tank. You can kind of switch those out pretty easily between materials. Just swap that cartridge and then take out that tank. We have covers that come with the tank, so that's going to stop any UV from getting into them. Some of them are also translucent on the bottom, so they don't have kind of a tank case, but you just need to put them on an opaque surface. So feel free to leave that resin in the tank. You don't need to dump it out, clean the tank, anything like that. They're kind of meant to be stored with multiple materials in a library up on a shelf. Let's see. We have another kind of workflow question about shrinking parts. So let's see, fit two together. So in terms of our capabilities within Preform, there are a couple of things you can do. Mostly what we're able to do is uniform shrinking and scaling. So you can't necessarily scale or shrink kind of the X or the Y. It's just you're scaling the whole part all at once. Sometimes if I'm not sure if things will fit together, I'll actually print multiples of them and kind of do different scaling factors just to see. If you want to kind of tune it in more than that, you would actually have to take it back into the CAD software. But then depending on the printer type you're using, there are some scaling factors available within advanced settings. If you're seeing that, you know, everything you're printing for this project needs to move in the X or the Y, you can make that adjustment. We have a question, we'll just keep going on the workflow ones, avoiding support structures altogether. So assuming this is in the kind of SLA space, there is a way that you can avoid support structures altogether, and that is by designing your part so that it can actually just print on the build plate without any support. So What that looks like is you'll need kind of one flat surface that's able to go on that build plate and provide support to the rest of the part. And then you need to be careful about kind of how fast and what angle you're building off of that part with. So make sure that those kind of subsequent layers are building off a solid base there. And we have a support article called Printing Directly on the Build Platform. So I would check that one out. It has some nice visuals that you can see. But generally, one of our favorite things to do for kind of minimal post-processing and kind of production applications is to print a bunch of parts that are all able to print directly on that build platform. And then we have a flexible build plate, and that will just pop the parts off and then minimal post-processing. So that's nice if you can get that into your workflow. We have a question for Bruno about how you got started at Ford. So a little bit of a pivot, but if you want to talk about that.
Yeah, I'm a mechanical engineer. So maybe you noticed from my accent, I'm coming from Portugal. So in Portugal, in my, let's say, city, there's a very culture or injection molding in Leiria. So, and was a very big advantage for me in working at Ford, especially having this background in injection molding, and was very good for Rapid Technology Center in Marrakech. So, and yeah, with my background in engineering and my background also in injection molding, I step by step was going using this knowledge, including additive manufacturing to produce prototypes.
Perfect. And another one, let's see. So there is a question about using some kind of magnetic materials in the printer. This one, so we have an open system now on the resin side and also the SLS side. Depending on kind of how those materials are curing, you could essentially take a third-party material and put them onto our printers. On the SLS side, it needs to be compatible with our laser. On the SLA side, it needs to cure at about a 405 nanometer. Depending on kind of the specifics of these materials, you may run into some kind of printability challenges because of some of the kind of sensors in the machine. So if they are kind of magnetic, may interact with some of those. But we do offer the opportunity to open up the printers. It's just it would be on the customer to determine whether those are going to print, what settings you need, and then whether that's kind of compatible with our architecture or not. And then our last question, it looks like here, kind of tips for changing between traditional prototyping into 3D printing, and tips for kind of shifting the organization. So I think what I've seen a lot of is we'll have kind of one person on the team who's very into 3D printing, and they'll bring in a printer and start using it, and then the rest of the team can start kind of just getting familiar with it, seeing how it works. And then once there's a printer kind of there that they can use, then they start coming up with ideas and kind of dipping their toe in and getting more experience. Yeah, so I think in terms of kind of team layout, it's going to change by organization pretty heavily. Another thing that I've seen is kind of a central 3D printing lab. So we'll see kind of one additive center, and you'll send all your parts there. So yeah, lots of different things you can do depending on kind of the layout of the company. All right, so I think that is it for questions. If anyone has any more, you can put them in now. We'll give you a minute or so. All right. Perfect. So if you have any kind of other questions, feel free to get in touch with the Formlabs team. Thank you again, Bruno, for joining us. It was great to hear your insights.
Thank you.
All right. Have a great rest of the day, everyone. Thanks again for joining us.